Okay, this is a video on 2.3 inequalities. I'm going to go through the first bit is just reminding how we write inequalities, how we write it then in interval notation, and how we represent it on a graph. Stuff you've all done before, but just good to refamiliarize ourselves with it. And all this, of course, is just kind of solutions to a problem, an inequality problem. I haven't actually given a problem yet, but how we write inequalities. All right, so inequality notation. X is less than 5 and greater than 2. So I would just write this as less than 5, greater than 2 in interval notation because it's not inclusive. It would be with parentheses, and how you represent this on just a little line graph here. It's everything between 2 and 5 exclusive. Okay, so given that, try the next, let's see how many. Pause this video and try the next 1, 2, 3, 4, 5, 6, 7 lines here. And then we'll talk about number 1. Okay, now that you've had a chance to go through, let's just quickly fill this in. So we've got X is less than or equal to 3, greater than -7. So -7 to 3, and the 3 is inclusive. And this time the -7 is open circle, but the 3 is filled in, and it's everything in between. Okay, X is greater than or equal to 10, so just greater than or equal to 10. So 10 to infinity with a bracket, and the number line is filled in at 10 and everything to the right of that. Less than 4, -infinity to 4, and 4 open circle, everything to the left. X is at least 6 and not more than 10, so between 6 and 10 inclusive, so that means you'll use brackets, and 6 and 10 there. Now we've got, and everything in between, X is less than 4 or X is greater than or equal to 7. So in this case, I can't write it as just one single inequality. I have to write X is less than 4 or X greater than or equal to 7, in which case when I write it here, I'm going to use my union symbol, which we're now used to. So 4, everything to the left and not including 4, and then 7 filled in, everything to the right. Next one is X is greater than 4 or X is less than or equal to 7. So greater than 4 or X is less than or equal to 7. Okay, well the interesting thing here is because it's an or problem, it means just one or the other has to be true. So greater than 4 or less than or equal to 7, it means it's going to be everything in the number line is covered by one or the other. Okay, X is greater than -2 and less than -6. All right, greater than -2 and less than -6. So if I were to think about that, greater than -2, whoops, let's not do that. Okay, greater than -2, so, or less than -6. Sorry, not or, and. So since it's an and problem, you need overlap. So there's no overlap here. So that means there's no solution. There's no solution for the interval notation, and it is just an empty set. There's no graph. So let me just erase that piece. All right, just no solution. Nothing in that graph. Okay, let's now go to a bit of the meat of what we're going to do today. So you are very familiar with linear inequalities, meaning you would just have something like X minus 4 greater than 0, or you could have X plus 1 greater than 0 or less than 0. And to do that, you just isolate the X, and there you have your inequality. And then the only thing you really have to worry about with linear inequalities is making sure if you multiply or divide by a negative, you switch the inequality sign. Well, in this case, if I were to FOIL it out, I actually have a quadratic inequality. So I can't treat it the exact same way. In other words, I can't do just what I did here. I can't just set each parentheses greater than 0 and solve and get X greater than 4, X greater than -1. The reason I can't do that is notice these two quantities are being multiplied by each other, which means if one's positive and one's negative, that's going to result in something less than 0. If both are positive or both are negative, then it results in something greater than 0. So they're interacting with each other. So before I go to A, let's go to B. So one good way to figure out a kind of a goof check of a solution, even though we haven't found our solution yet, but a good starting point may be to see, would infinity and negative infinity be part of my solution? So I think about if I plug in a huge positive number for x, so something huge, say 1 million, and for x, would that result in something positive? Would that make this inequality true? And yes, it would. So I would expect infinity to be part of my solution. Let's do the same for negative infinity. If I put in something like negative 1 million, negative 1 million plus 1, that's going to be a big negative times another big negative, which is also going to be positive. So I would expect both infinity and negative infinity to be part of my solution. It's a good check when you get your solution to do that, just to see if those should be a part of it or shouldn't be a part of it, and if you got that or not. Okay, so now let's go back to this original problem. So notice if I had just gone and given this as my solution, which doesn't really make sense. I mean, there's overlap with those two. It would hit infinity, but negative infinity wouldn't be a part of the solution. So something's amiss. So to figure out how these two interact with each other, I'm going to do something similar to what I did with absolute value. I want to figure out where both of these quantities in this factored form, where they equal 0, because that's where each of the parentheses is going to change sign. So the first quantity changes 0 at 4 and the second at -1. So if I put those on a number line, we're going to do what we call sign analysis. So if I plug in a value, so let me put x minus 4, x plus 1, and I want to see where it's greater than 0. If I put in a value greater than 4, say 5, in for x, I'll get this being positive and this being positive, which will result in something positive. So greater than 4 is going to be positive. If I put in something between -1 and 4, 0's I think the easiest, I'll get negative here, because 0 minus 4 is negative, and then I'll get positive here. And a negative times a positive is going to be a negative, so it's going to be negative between -1 and 4. And let's put something to the left of -1, like -2. I'll get negative, negative, which is going to result in a positive. Now, I go back to the original question now. Here's my little sign chart here. And I figure out, what am I solving for? Well, I'm solving for values that are positive or greater than 0. So my solution in this case will be negative infinity to -1 union 4 to infinity. And I should have put circles here. Because it was only greater than 0 and not equal to 0, we were not going to have those circles filled in. We weren't solving for the 0 case because it did not include equality. So this is what we call sign analysis, and you're going to be doing this a lot this year. Let's go back here. I think it's the same problem. Another here. All right. Well, the less than 0, is it the same problem? No, it's a little different. All right, let's just do it then. All right, so again, two quantities multiplied by each other. So I've got one equals 0 at 7, the other at 2. Again, I'm looking for less than 0, so not equality. So if I put in something greater than 7, I'll have a positive times a positive, so that'll be positive. If I put in something between 2 and 7, I'll have negative and I'll have positive, so that will be negative. And if I put in something less than 2, I'm going to have, like 0, I'm going to have negative times a negative, which will make that positive. So my only solution, since I'm looking for the negative or less than 0, will be 2 to 7. So the interesting thing here is notice how, because each of these degrees, each parentheses was raised to the first degree, it meant it was always changing sign on either side of every value. So notice it went here from plus, minus, plus. So it was alternating signs each time. That's not always going to happen. In particular, it won't happen if you have a quantity that's raised to an even power. Because whether you're to the left of that particular number where it equals 0 or to the right, it's not going to change sign because of that squared. Let's see what I mean. Let's do 3b. So if I do 3b, I get my two values I'm going to put on here are 3 and 9. And because I'm looking for greater than or equal to 0, I'm going to fill in the dots because the equal case would be 3 and 9. That's where this would equal 0. So I want to fill that in. All right, in doing sign analysis, let's start with 9. If I put in a value bigger than 9, I get positive and then positive. So I'm going to be positive. If I put in a value between 3 and 9, I'm also getting positive. But notice normally if I, actually messed that up there. Let's restart that. I am not getting positive there. Okay. All right, so greater than 9 positive, going too fast. Between 3 and 9, if I put in a value like 8, the squared part will be positive, of course, but 8 minus 9 is negative, so I'm going to get a negative. So notice on either side of 9, it switched signs, which makes sense. Again, this power is to the power of 1. So on the right side of 9, I happen to be positive. So on the other side of 9, it changed to negative, which happens if that little exponent, which if there's nothing there, it means 1. If that's an odd power, it's going to change sign across the number. However, notice what's happening at 3. So we just said to the right of 3 was negative. Well, if we put in values to the left of 3, the x minus 9 is still negative, but normally if I didn't have that little squared, x minus 3 would also be negative, but in this case, because it is squared, it's going to be positive. So this whole quantity is going to remain negative. So it didn't change sign on either side of that 3 because that 3 came from x minus 3, which was squared. So when I go to give my solution here, it's just going to be 9 to infinity. Oh, be very careful. And also the value 3, right? We don't want to forget the equality parts. So 3 is also a solution. So I've got to put that as well. 3 and then union 9 to infinity. Let's do another like that because that was interesting. All right, let's do D, and then I'll have you do the harder ones by yourself just to give it a try. So here, the numbers I have are -2, 3, and 5. If I put something to the right of 5, I am getting negative, positive, positive. So we're going to have negative. Oh, and let's fill in the circles because equality is included. And then it should change signs on either side of 5 because the exponent here is 1 since there is nothing there. It should then on the other side of 3, because it's squared, it should remain positive. And we can check, like let's check to the right of 3. If to the right of 3 all was positive, now let's check to the left of 3. If I put in something like 0, it's still all positive. And now to the left of -2, because x plus 2 is raised to the first power, it should change sign across that. So if I put in something like -3, indeed it is negative. So now if you're uncomfortable with that at this point about when it alternates and when it stays the same, feel free to plug in values. You can always plug in values in the interval just to see what's happening. Let's answer this question though. So the solution we wanted greater than or equal to 0. So it's going to be -2 to 5. And notice included, all the dots are already included in there, the filled in dots, so I don't have to worry about that like I did in B, because in B that 3 wasn't included in the interval. Okay, so try the rest of 3 and check your solutions when you finish, and then you're gonna watch another video to move forward.